So suppose you want to find vector and parametric equations for the line passing through 1, 0, and 3, negative 4. The points 1, 0, and 3, negative 4. So here's 1, 0, and here's 3, negative 4 down here, let's say. I can look at that. I've got a line going through 1, 0, and 3, negative 4. Put some point on that line, call it P. So vector addition, the vector 1, 0 plus some scalar multiple of the vector 3, negative 4 is going to yield my output vector here, x, y. And so if I set that up, then I'm looking at xy is going to equal the first vector 1, 0 plus some scalar multiple, we'll let our scalar be t, of that vector between 1, 0 and 3, negative 4, which is negative 2, negative 4. So there is my vector equation for the line that contains 1, 0 and 3, negative 4. And then if I want to go ahead and generate the parametric equations for that, I know that x then is going to be 1 plus negative 2t, and I know y is going to be 0 plus negative 4t. So again, x is going to be 1 minus 2t, and y is going to be 0, so we'll just write that as 0 minus 4t. So there's my parametric equations for the line, and there's my vector equation for the line that passes through the points 1, 0, and 3, negative 4. And again, the key is to see one vector plus a scalar multiple, another vector, gives me my output vector, and I've let xy simply be a point somewhere on this line such that my vector runs from 0, 0 out to xy. So suppose I want to find the vector and parametric equations of an object whose velocity is the vector 3, negative 1, and its position at t equals 0 is 2, 3. So I'm looking for a vector here. If I think about it, I'm looking for a vector equation such that xy is going to equal, it's got a constant velocity of 3, negative 1. So I know then my velocity vector, if I think about it, 3, negative 1 is going to look something like this, over 3, down 1. And I know my initial position, it tells me, is at 2, 3. So if I'm up here at 2, 3, and then I know that in 1 unit of time, I'm going to go over 3 and down 1, I could set up and do kind of the same problem that I just did before, because I would have then 2 points, and I'd simply be writing the vector equation through 2 points. I could also view it as if my initial position at t equals 0 is 2, 3, we'll go ahead and say you're going to start at 2, 3 plus, I then know I'm going to have some multiple of that velocity vector to get me to my next position. So there's going to be my equation for my vector equation for this situation. The parametric equation is the same we just did. X is going to be equal to 2 plus 3t, and y is going to be equal to 3 minus t. So x is 2 plus 3t, and y is 3. Whoops, write that a little more carefully. Y equals 3 minus t. And there are my parametric equations. So at some time t, position of an object moving with a constant velocity is given by those parametric equations here, 1 plus 3t and 2 minus 4t. So we're first asked to state the velocity and speed of the object. So let's see. If I look at these, can I come up, if I look at this system of the parametric equations here, can I come up with what my vector equation would be for this situation? And certainly I can. My situation would be xy equals 1, 2 plus t times 3, negative 4. Note that this 3, -4 is going to be, I'm looking at a scalar multiple here to add on to my starting position. So if I let t be 1 in 1 unit of time, I then will have gone a velocity vector of 3, -4. So my velocity vector here is going to be, 3, yep, sorry, space got distracted. Yes, my velocity vector, after going 1 unit, after letting t be 1 unit, my velocity vector is indeed going to be 3, -4. So if that's my velocity vector, my speed is defined to be the absolute value of velocity, and so therefore my speed, which is my absolute value of that velocity vector, is the absolute value of 3, -4, is going to be square root of 3 squared plus 4 squared, or 5. So when and where do I cross the x-axis? Well, to cross the x-axis, I would have to let y be 0. So when does y equal 0? Define y up above is given to be as 2 minus 4t. So set 2 minus 4t equal to 0. That implies t equals 1/2. So that's when it crosses the x-axis. Where does it cross the x-axis? Plug in t equals 1/2 into your equation for x up here, and that would then yield 1 plus 3/2 equals 5/2. So I cross the y-axis at t equals 1/2. At t equals 1/2, looking at my parametric equations here, at t equals 1/2, x is 5/2. So I cross on the x-axis at the point 5/2, 0. So finally, just a little bit about changing to parametric mode in your calculator. If you got your calculator turned on in front of you, you hit mode, you slide down, you've got normal scientific engineering, you then are floating your decimal points, you then can be in radian degrees. Sliding down to the 4th line, you pick parametric, which is the second option, which is PAR. If I then look at my y equals, I'm going to see I have an x1 of t equals and a y1 of t equals. So then you can load in equations, like we've just formed parametric equations, and graph them. So how to graph these things? Go ahead and load into your calculator -2 plus 7t and 3 minus 2t in for your x1 and x1 of t and y1 of t. So that this is going to be your x1 of t, this is going to be your y1 of t, and if you put your cursor on the equal sign on the x1 of t and keep sliding, you're going to click 1 to the left, and you're going to be over to the left of that x1 of t, and you're going to see kind of a dotted line that looks something like this right here. If you then hit the enter key, it's going to turn and look something like this. You hit the enter key again, it's going to give you something that looks like this, and I call this the snakehead. Select that snakehead option. Make sure that snakehead option is turned on, and you've turned it on. You should see it there flashing at you, and if you then just take your right arrow key and you can go back, and that snakehead will stay there as a snakehead now. What you're going to do now is want to graph. You're going to want to graph this equation here that you've got, and to do that, you want to hit the window button, and you want to set up a good window and a good t-step to see your graph be traced out. So let's say we want to start at t-min is 0. So you'll type in t-min is 0. We'll start with a t-step, or t-max of 5, and a t-step of 1 to start with. And then you're going to have to figure out where do you want your x-mins and x-maxes and y-mins and y-maxes to be. Because remember, what you're graphing here, this is parametric equation for a line. So you're graphing a line somehow. And you could put this back into Cartesian form if you wish. Or you might just have to play around and figure out what your x-min, x-max, y-min, y-max need to be to see the picture of the line. Go ahead and do that and see if you can then hit graph and see if you can see the line sketched out. you should be able to see it, and it's going to move very quickly because your t-step initially was 1. Do the same thing again. Go back and hit the window key and change your t-step to 0.1, and it's going to trace out the graph, the head of the graph, more slowly. And so this indeed is how we can see a parametric graph traced out. As t changes, we can see what happens to, dynamically see what happens to our x and y and see the graph traced out. And there are some very cool parametric graphs that we may or may not have a chance to look at. Minimally, we've done parametric equations of lines. So again, if you didn't think about converting to back to Cartesian form from your parametric form, here I've given you two parametric equations for some Cartesian graph. How can I write this in terms of y in terms of x? And it's real simple. I've got a y in terms of t. Let's solve this for t in terms of x and then simply plug in. So I've got up here then, let's see, I would have 4t equals 5 minus x if I solve for 4t. And then if I solve for t, I get t equals 5 minus x over 4. Go ahead now and plug that in for t here, and I would get y equals -2 plus 5 minus x over 4. Note now you've got an equation in terms of y in terms of x. To simplify that first, I might multiply both sides by 4 just to clear out the denominator, or I could go ahead and write this as y equals 5 quarters minus x over 4 minus 2. And note that I then indeed, when I combine these two constants together, I'm going to get the equation of a line with a slope of -1/4.